Good morning, afternoon. I'm looking at 6.5, page 355, and we're multiplying polynomials. And so let's just start without any further ado. So, multiply these two monomials. So, you multiply this term by this term. Now, remember the terms have variables, exponents, and coefficients. So you can group the coefficients together. You can multiply 6 times 8 and the variables, which are powers. And so 8 times 6 is 48. Powers have the same base, so add the exponents. It's that simple. I'll be moving quick. Same idea here. Two terms, multiply them. So I'll group the coefficients of the powers. I'll group the variables that have the same, well, actually, they're powers again, that have the same base. Okay? Don't forget that the single variables do have a power of 1. Don't you forget that. So 10 times 7 is 70. 5 plus 1 is 6, so it's s to the 6th power. 1 plus 4 is 5, so it's t to the 6th power. Moving on. Number 5. A single term multiplied by a binomial. And so we use the distributive property. So again, I'll show each of the steps. So it's 2x multiplied by 3x. And I'm going to write plus, okay, 2x times negative 4. Okay? And again, my idea here is that when it says 3x minus 4, I often view this as a addition problem, and I bring the negative sign up. You can do that with every single subtraction problem. Okay? And so this gives me 6x squared plus negative 8x. Now, this can also be written as a difference. Again, I'm going to keep stressing that these are identical statements, okay? Moving on. First outer, inner, last FOIL method, or you could use generic rectangles if you'd like. But for the sake of time, I'm just going to multiply through. I'll take x, multiply it by x. X multiplied by 4x. 3 multiplied by x. And 3 multiplied by 4. So we end up with x squared plus 4x plus 3x plus 12. Combining like terms, making sense, I hope. Next one. Okay? Next question. There are no like terms to combine. Okay, 2 more questions. Okay, so I'll use the technique here of distributing again, but I'm not going to show every single step, okay? That easy. Last question. The length of a rectangle is 8 centimeters less than 3 times the width. Write a polynomial that represents the area of the rectangle. And B, find the area of the rectangle when the width is 10 centimeters. Reading this first sentence, if I knew the width, I could calculate the length. Okay? 8 centimeters less than 3 times the width. But I don't know the width, so I'll call that x. So according to the information, 8 centimeters less than 3 times the width is the length. Okay, after looking at the question in a different light, what I wrote here would read as the length is 3 times 8 less than the 8 centimeters less the width. And so you don't necessarily need these parentheses here, so this essence should be written this way. Let me rewrite this. Okay. The length is 3 times the width, right? And 8 less. So 8 less than 3 times the width. So 3 times the width would be this portion here. 8 less is that minus 8. Okay? So that's the proper way of writing that. So it's tricky. Now, so write a polynomial that represents the area. Well, the area of a rectangle, for letter A, and so substituting, we get, and I'll switch it around where the width is x. I'll write that first. And so that's the length times the width. Now distribute. There it is. It's a quadratic polynomial that represents the area of the rectangle. Now B, find the area of the rectangle when the width is 10. Okay, so when x is 10, what's the area? So let's substitute. A 100, 300, minus 80. And so our answer is 220 square centimeters. Okay, and that's a wrap. All right, guys, like I always say, study hard and learn a lot. And we'll see you soon. Bye-bye.